I understand you want to learn more about radiation in space.
Yes, we've read that radiation is very dangerous, but we're not exactly sure what it is.
Well, radiation is one of the top biological concerns for our astronauts. There's two basic types of radiation, light and particles.
How is light dangerous?
Light comes in many different forms. The low-energy visible light that you're familiar with isn't dangerous. But light comes in a high-energy form called ultraviolet.
Isn't that what causes sunburn?
Well, that's right. X-rays and gamma rays are another form of light with more energy than ultraviolet, and they can cause serious damage to your body's cells.
What about the particles?
Very fast-moving particles are considered to be radiation. One example is high-energy protons, which are released by flares on the sun. Another, even more dangerous type of radiation are galactic cosmic rays, or GCRs.
What's a galactic cosmic ray?
GCRs are extremely fast-moving protons and nuclei of elements such as iron, silicon, and other elements that come from outside our solar system.
Why are they so dangerous?
They can penetrate more than 100 centimeters into materials and can cause a lot of cell damage. They are also very difficult to shield against, and they can even create additional radiation when they collide with metal spacecraft.
Wow. I've heard that radiation can increase your chances of getting cancer. Is that true?
That's correct. The greater the radiation exposure, the greater the risk of getting cancer and other effects such as cataracts, which is a clouding of the eye lens.
What determines how much exposure you get?
The length of the mission is one of the most important factors. A mission to Mars could take several years. Longer missions mean greater health risk from radiation exposure, especially compared to space shuttle missions, which are much shorter. However, NASA is working hard to reduce the risk.
What are they doing?
They're developing better shielding materials that will prevent the radiation from reaching the astronauts in the spacecraft. And high exposures can also come from very intense events, like solar flares.
Isn't that when the sun has a solar storm?
Very good. If you can monitor the sun for solar storms that produce these flares, then you can warn the astronauts to avoid spacewalks and to enter specially shielded storm shelters in their spacecraft.
Is there anything that can help the body handle the effects of radiation exposure?
Well, NASA is looking at how a healthy lifestyle, including dietary vitamin supplements, might provide protection. They're also looking at the role that age, gender, and/or genetic factors play in how the body responds to radiation.
Wow. If radiation is such a problem for astronauts, why don't we have to worry about it on Earth?
We do have some radiation on Earth, but we're protected from most of it by something the astronauts don't have, an atmosphere.
Yes. I learned in my science class that an ozone layer of our atmosphere blocks a lot of the ultraviolet light from getting to Earth.
Well, that's correct, and it also absorbs a lot of X-rays, gamma rays, and high-energy particles. Charged particles, like cosmic rays and protons from the sun, are deflected by Earth's magnetic field, and Earth itself acts like a big shield.
I'm glad that we have some protection. Radiation sounds pretty serious.
Yes, it is. So don't forget, you should always wear sunscreen when you're working or playing outside.
Don't worry, I will.